We finally reached the chapter that discusses what quality means. I'd argue that this chapter should be at the beginning of the text, but better late than never. Our personal definition of quality is consistently meeting customer value expectations. That key word is consistency, which means regularly or free from variation. Again, variation is the killer of quality. The text definition of quality originates from ISO, the International Organization for Standardization. They say quality is the degree to which a set of inherent characteristics fulfills requirements. So these two definitions are directionally similar. We say expectations, they say requirements. The text lists three potential sources of customer requirements. Number one are customer expectations, which are stated or implied values. And a simple question to ask here is, what do our customers want, or what will satisfy them? Number two are regulations, which are obligatory. And number three are brand expectations, which extend beyond the product or service to a higher level identity and emotional connection with the customer. For instance, we all know the Coca-Cola brand. It's extremely strong globally, and it permeates all of their products. We differentiate two terms relative to quality. The first is critical to customer, CTC. What does the customer want? That is, what is the voice of the customer, the VOC? And then second is critical to quality, CTQ. What must we do specifically internally with the products and services to achieve those customer wants? That is, the CTQs look at the major drivers of quality within the organization or a specific process. And these CTQs can be measured and represent internal concerns, meaning what can we do about it? So CTCs and CTQs sound very similar, and they are closely related. However, critical to customer, CTC, includes external expectations that are often broad and abstract. For instance, we want our online order to be delivered fast. Then critical to quality, CTQ, helps us to internalize the customer expectations into specific metrics. For instance, we commit specifically to 2-day delivery. Again, CTQs tell us what we need to do internally to meet customer expectations. And following the 80-20 rule, CTQs are the few factors that drive, say, 80% of customer satisfaction, allowing for substantial improvements of that satisfaction. And we can use a CTQ tree to convert customer needs, meaning the CTCs, to detailed quality requirements. These specific requirements can then be easily measured to guide process performance. And we'll create one CTQ tree for each critical to customer CTC need. The text presents an example of a CTQ tree for repair appointments for HVAC, heating, ventilation, and air conditioning. The high-level customer need is excellent service. And this is a factor of three drivers that customers want, but are still not necessarily measurable, including friendly technicians, knowledgeable employees, and timely service. then these three drivers are broken down in more detail to develop specific measures. The first is friendly technicians. For instance, technicians receive an average score of satisfied or above on customer evaluations, including no more than 2 complaints per quarter. Second is knowledgeable employees. For example, the organization receives an overall customer satisfaction score of excellent on at least 70% of evaluations, and technicians receive an average score of satisfied or above. Third is timely service. Specifically, customer calls are returned the same day, 90% of the time, and technicians arrive in the quoted time window 90% of the time. And further, technicians arrive within 48 hours of the original customer call. The text emphasizes that quality always comes at a cost, and it differentiates the cost of poor quality, COPQ, which is created by defects, internal or external to the organization. So the cost of poor quality is external failure costs plus internal failure costs. Then second is the cost of quality, the COQ, which includes the cost of poor quality, but also the cost of maintaining good quality. So the cost of quality is the COPQ plus prevention costs plus appraisal costs. Let's first look at the cost of poor quality, which again includes external and internal failures. External failures are defects that have reached the customer. They're external to our organization. So direct impacts may include returns, repairs, and warranties. And then internal failures are defects that have been caught before reaching the customer. They're internal. So the impacts are simpler and less severe, but still potentially costly, such as scrap, meaning they're thrown out, or rework, meaning they're fixed. Generally, external failures are likely more costly than internal failures. That is, we'd prefer that any defects be caught internally rather than be experienced by the customer. The cost of poor quality, COPQ, can include a lot of hidden costs that are difficult to see and measure, like loss of customer loyalty, including customer ill will and negative word of mouth. Then we also have to consider impacts on employees, like loss of employee morale, and then the loss of those employees if morale remains low for extended periods of time. And we also have to consider conflicts associated with scheduling or rescheduling and higher risks of compliance issues, including fines and higher administrative costs, and then unpredictable revenue, sales, or production. And the text states that calculating the cost of poor quality is extremely difficult at the enterprise level, and it's still moderately difficult on a process level. So this presents a challenge to process improvement in justifying our projects. That is, if the benefits are difficult to quantify, the return on investment, ROI, will be less clear. And that can be detrimental to support from organizational leadership. The cost of quality, COQ, includes the cost of poor quality, but also adds efforts to improve quality, including reducing defects. So the cost of quality adds prevention costs, such as mistake proofing, known as poka-yokes. And these are meant to stop an error or a defect from occurring. And then also appraisal costs include any activity used to assess and or ensure high levels of quality across a process or the organization. Examples of appraisal costs may include quality control specialists and quality inspectors, then also quality audits and field tests, and then calibration and measurement equipment or software. And then we also might include security checks and safety checks, as well as supplier certifications, and even employee surveys and customer feedback. Again, prevention seeks to stop defects from occurring in the first place. So examples may include error proofing and quality planning and reviews, as well as quality education and training, and then quality review and evaluation processes, and then also possibly customer surveys, and then creation of technical manuals, as well as work to create and manage requirements and specifications, management of job descriptions, and even housekeeping to reduce errors in production. Poka-yoke, or more specifically, poka-yoke, is the Japanese term for mistake proofing. So we see but often overlook everyday examples such as a filing cabinet that only lets you pull one drawer out at a time, so the cabinet doesn't tip over on you. And this is a serious problem that still happens today. Or placing your foot on the brake before putting your car into drive. That's in case the car accelerates on its own, which actually happened to some models in the past. As we implement process improvements via Six Sigma and Lean, the costs of quality will likely go down as quality improves. And this effect is generally exponential, meaning that the gains accelerate over time. For instance, the estimated cost of quality for a 2 Sigma process can exceed 40% of sales. In contrast, a process achieving a 6 Sigma level of quality has estimated quality costs of less than 1%. As such, Six Sigma seeks to build quality into every process with the goal of zero costs of failure. Realistically, this may not be fully achievable, but will keep us pointed to an environment of continuous improvement. As a starting point, concentrate on failure costs. That is, defects including external and internal failures. Once we eliminate those, we can turn to prevention and appraisal costs. And ideally, prevention is the definitive level of quality. Specifically, preventing defects from occurring will eliminate external and internal failures. So a mistake-free process doesn't even need appraisal. In this line of thinking, Six Sigma processes are self-regulating, meaning that they can detect, correct, or even prevent defects automatically rather than relying on manual inspection.